In this video, we are going to go ahead and finish up section 6. We have to graph polynomial rational functions. And what we'll do is I'll take you through the procedures on how you find all of the vertical asymptotes, horizontal asymptotes, any some significant points so that we can graph. The first one that we're going to do is f of x equals x plus 1 over x squared minus 1. One thing to keep in mind is that you need to look to see if any of your polynomials, whether it's on top or bottom, can be factored. Now the reason why you'd want to try to see if your polynomial can be factored is because then what you're going to do is be able to simplify it. So this first one here, you can factor the bottom. It's the difference of squares, so it's x plus 1 and x minus 1. Which indicates that you can simplify this down to 1 over x minus 1. Now here's our little rule that we have. Since I can cross out the x plus 1, then I have a whole. You do x plus 1, and you set it equal to 0 since we can't divide by 0, and x would equal negative 1. This is going to indicate that I have a whole at negative 1, and then in order for me to find where the rest of the y value, or what the y value is at that whole, is you're going to substitute negative 1 into your function. And when you do that, you get negative 1/2. All right, so let's go ahead and do our first part of our sketch, and I'm going to put a whole at negative 1, negative 1/2. You just want to do that whole with an open circle. All right, for the rest of my polynomial, what I'm going to be doing is I'm going to be using the reduced expression. So from here, we're going to decide if there's any vertical asymptotes. Vertical asymptotes would occur when the denominator equals 0, so at x equals 1. I'm going to go ahead and put that in here, a vertical asymptote at x equals 1. And horizontal asymptotes would occur, you want to compare the degree. The degree on top is 0 and the degree on bottom is 1. So when you go ahead and look at all of that information, it indicates y is equal to 0 is a horizontal asymptote. So I'm going to place that one in there as well. All right, the next thing that you're going to do is plot points. And you're going to build a table of values like this. And you can plot a couple points. I already know I have this 0, negative, or negative 1, negative 1/2. What happens if I put 0 in? If I put 0 in, I get 1 over negative 1, which is negative 1. Plot it. All right, here's what I know about my curve. It's slowly going to approach the asymptote. It's going to pass through the hole. There's the first part of my curve. And then I have to go ahead and graph the other half. I want to pick numbers that are to the right of my vertical asymptote. So let's go ahead and pick 2. What happens when you put 2 in? You get 1 over 1, which is 1. So I'm going to plot the point 2, 1. And let's put in 3. 1 over 3 minus 1, which is 1/2. Plot the point over 3 up 1/2. And this also will slowly approach the asymptote. And so this is what your graph is going to look like. And that's all that you have to be able to do. You need your asymptotes, your whole, and a quick sketch. All right, let's go ahead and look at the second one here. I don't have any factoring that I can do, so I'm going to go directly to finding the vertical asymptote. The vertical asymptote would be when the denominator 4x minus 6 is equal to 0. So this is 4x is equal to 6. X would equal 3/2. So x equals 3/2 is my horizontal asymptote. I'm going to go ahead and put that in there. So at 1.5, my vertical asymptote. Now let's look for a horizontal asymptote. Horizontal asymptote, you compare the degree. The degree on top is 1, the degree on bottom is 1, so it is y equals the coefficients of 2/4, which is 1/2. So I'm going to go ahead and place in there my horizontal asymptote at 1/2. All right, from here what we will do is we'll build a table of values like this and plot some points. And that should give us enough information to graph it. So let's go ahead and see what happens. Let's go to the right side of my vertical asymptote at x equals 3/2. Let's put in 2. If you put 2 in, you get 4 plus 5. That's 9 over 8 minus 2, or 8 minus 6, which is 2. So 9/2. So over 2 and up 9/2, which is 4.5. So right about there. And if I put 3 in, I get 11 on top and 6 on bottom. 11/6 is 1 5/6. So over 3 and up 1 5/6. And what you can do now is go ahead and draw your curve and make sure they slowly approach those asymptotes. All right, what we're going to do now is look at x values that are to the left of. So let's put in 1. If I put 1 in, I get 7 over -2. So -3.5. 1 -3.5, which should be about right here. And let's do one more. Let's put in 0 for the origin. For the x value 0, you get 5/6, and it's -5/6. 0, -5/6 is about right there. Your graph is going to slowly approach the asymptote and also pass through those 2 points. And that is the graph of this rational function. And these are the most important parts right here. All right, graphing x squared plus 1, or x squared over x plus 1. There's no factoring that I need to do, so this is going to be the polynomial that I actually use. We'll start with our vertical asymptote. You set your denominator equal to 0, and you solve it. And x then is equal to -1. So x equals -1 is my vertical asymptote. Let's go ahead and place it in there. And then the next thing that we're going to do is look to see if we have any horizontal asymptotes. Horizontal asymptotes, you compare your degrees. You got 2 on top, 1 on the bottom. That's greater than, so there are none. There are no asymptotes. You're comparing this 2 with this 1. All right, but because that degree on top is 1 more, we have a slant asymptote. To find the slant asymptote, you do long division. Go ahead and insert some placeholders here, 0x plus 0, and on the outside is your divisor of x plus 1. I'm going to divide, and you get x, multiply it down, subtract, you get -x, bring down the 0, and divide one more time. -x divided by x is -1. Multiply down, subtract. The remainder doesn't matter. What we're looking for here is the equation of y equals. This is your slant asymptote. And so what you can do is you can graph it using slope-intercept form. My intercept, my slope. There we have it. From here, what you're going to do is you're going to build a table of values, x's and y's. And you're going to plot points so that you have points on both sides of your vertical asymptote. Let's go ahead and look at some points that we're going to pick. Let's go ahead and find out what happens when x is 0. If you put 0 in, you get 0 over 1, so 0, ordered pair, the origin. Let's put 1 in. 1 would be 1 over 1 plus 1, 2, so 1/2 over 1 up to 1/2 right there. What I know about this curve is it's going to slowly approach the asymptote, go through my point, and it's all in a curve. They have to approach both of those asymptotes, and that's what it would look like. All right, let's look at what happens with the left side of my x, or vertical asymptote. Let's try substituting in -1. If I put -1 in, I get 1 over 0, which is undefined, and that's why I have that asymptote. So let's try -2. 4 over -1, which is -4. All right, so at -2, I go down to -4. And let's try to put in -3. -3 would be 9 over -2, which is -9/2, -4.5. Plot the point. And you can also see that this curve will come in and go towards both of those asymptotes. All right, there's an example of having a slant asymptote along with a vertical asymptote, but no holes. We got one more problem left, and it is an absolute value. When you do absolute value, you must take your function and write it into a piecewise function. And your piecewise function would look like this. You need to take and drop off your absolute value symbols, x plus 10 over x plus 2. Okay, so this is true since this absolute value of x has to always be positive. Then if this is positive, it's only because x is greater than or equal to 0. Now what you do is you drop off the absolute value symbols, but you represent the x as negative x. If we want this to be positive right here, if you want your x to be positive after substituting, then x has to be less than 0. So you have to be putting in negative solutions. There's your piecewise function. You'll always need to write your absolute value into piecewise because then you have the absolute value symbols away from it, and we're able to evaluate, and we're going to be graphing both of these parts. All right, let's look for vertical asymptotes. Well, if you can go back to the very beginning here, this expression will never equal 0 on the bottom. So you don't have any vertical asymptotes. You could use either expression. X plus 2, the only way that that'll be a vertical asymptote if it's negative 2. However, that's not part of the defined domain here. It's only for positive. And the same would go for the second one. So none. Let's go horizontal asymptotes. We actually have two horizontal asymptotes. The first one, the degrees are the same in both of these. The first horizontal asymptote would be the coefficients 1 over 1, so y equals 1. And that's coming right from here, 1 over 1. And then the second horizontal asymptote would be occurring at, and this is found from having 1 over negative 1. So y equals negative 1. When I graph these horizontal asymptotes, I'm only going to graph them for where their domain exists. So the first one's only to the right of the origin, and the second one is only to the left of the origin. It's time for us to graph. Build a table of values, x and y, like so, and substitute some points in. So let's go ahead and put in 0. If I put 0 in, I'm evaluating it in the first polynomial, the first function. So you put 0 in, you get 5. 10 over 2 is 5. Plot the point. And let's plot one more. Let's try putting in 2. If I put 2 in, you get 12 over 4, which is 3. And what we know is that this graph only exists to the right, and it's slowly going to approach that asymptote. All right, let's look at the other side. I'm going to put negative values in. I do know that it is going to come from this point. I just don't know what happens when it's at negative 1. If I put negative 1 in, I get 9 over 3, which is 3. And if I put negative 2 in, again, into the second expression here, I get 12 over 4, which is, let's try that again. If I put negative 1 in, I have 9 over 3, which is 3. And if I put negative 2 in, I have 8 over 4, which is 2. All right, this side of the graph goes all the way up to that 5, but slowly approaches the second asymptote, never crosses it. There's your piecewise function. All right, the last problem that we're going to look at is a modeling. It says a game commission has determined that if 500 deer are introduced into a preserve, the population at any time in T years is given by this function. So N is the carrying capacity, or it's the population in the preserve. If you start the population at 500, you can see here by my function that if I even put a number in, it's going to be increasing. So you're starting at 500 and then it slowly increases. And so what they're wanting to know is, when does it level off? It's going to level off at a horizontal asymptote. I can find that horizontal asymptote by looking at my polynomial. I've got a degree of 1 on top, a degree of 1 on the bottom, so you do 350 over 0.2. This indicates that my horizontal asymptote is at 1750. That is my answer. Now you can always graph this into your y equals and do some predicting for other years, or you could graph your horizontal asymptote and watch the graph slowly approach it. That is it for the section 2.6, and here is your assignment.